There you go. Just warn me when the time is.
30 or 29?
It's 29 minutes and 50 seconds when it stops.
Okay.
Okay, if I can have your attention. Hey guys, up here, your eyeballs. Okay. So basically, going back to Newton's basic law, I got MA equals the sum of the forces in whatever direction. So this could be in the x direction. Those are the x forces. Y direction doesn't matter. Okay. Now let's treat a simple case. If you have a block, and this is a real block that like just a cardboard box on the ground with a rope attached to it, does it take a force to pull it at a constant speed? Yes. Is it inertia that's resisting you pulling? No, it's friction. So now you're going to have forces that balance out, even though there's no acceleration, which is something new. But it's just simply so you have MA equals the force of tension. I've been using F sub T for that in the positive direction, and then the force of friction in the negative direction. And if this, so what I'm going to say is it's possible this box is moving. Let's see, force of tension. And why is I can't draw today. I can't write. The force of tension minus the force of friction. And this is going to be equal 0 if the box is not accelerating, if it's moving at just a constant rate. Now, does this box have to be moving to experience the force of friction? It's kind of a trick question.
Yeah.
It doesn't. Because if you're pulling it, but you're not pulling it hard enough to break it free, to break the friction, isn't there still a tension on the rope? So what? It's not the force of gravity because it's in the x direction. That's also the force of friction. But there's two types of friction. There's static friction and that's what I just talked about. Static friction and kinetic friction. Kinetic friction is after it's broken free and it's moving. Actually, for the same surface and the same two surfaces rubbing, these actually have different values. Which one do you think is bigger? This one will surprise you. Which? It is the static. That's why sometimes when you rub your hands on something, it squeaks. Because basically your skin grabs a hold and it doesn't want to let go until you push just hard enough, and then it releases and then grabs again like a spring, and it forms kind of an oscillation that makes a squeaky noise. Yeah, and then it just releases like the kind of springiness that's built up in your skin, and then re-grabs again. But that wouldn't be possible if static friction were weaker than kinetic friction. It would just slide if that was the case. But because these are because static friction is higher, it's able to grab, release, grab, release, grab, release, grab, release.
So how would you define static friction?
I'm about to. Okay, so static friction, he wants a definition. I'm going to give you a mathematical one. Static friction is defined as mu. If it's static, it has a sub s on it. This is a Greek letter mu times the normal force. The book might call this big N. I've seen that in a lot of text, but I just call it F. I call these forces, I use subscript to tell you what kind of force it is. Do you guys know what the normal force is?
Yeah, it's in the force mechanism.
Well, of course you know, because you had physics before.
We talked about it in this chapter.
Yeah.
Okay, that's true. The normal force is the force of the table pushing back on the object. And there has to be, if there's gravity, it's just, when it's a flat table, it's just equal to mg. It's pushing back. It's the force that's pushing back. So if you do the sum of the forces, there's no acceleration in the y, right? This is the sum of the forces in y, They all equal 0 because it's not falling, right? It's just kind of flat. Everybody following along so far? So in this case, the normal force would just be mg. So to find the force of friction, it would be mu sub s times mg. That's it, real simple. And you would look up mu sub s in a book, and it would tell you, oh, paper sliding on wood, or you look up, the different surface types, and that's just kind of a rough guess. If you really want to know, you actually have to do an experiment, and you have to measure it. And we have a lab. I have a lab. Basically, you can measure the mu k just by finding out the angle of, like, when you tilt up an object, how high you have to tilt it before it breaks free and slides. That'll give you the mu sub s. And then to measure the mu sub k, I have a little, in here I have little force meters, and you can pull that object along the table at a constant rate. You can't accelerate. And then you can kind of get an average on the little graphs that print out of the computer. You just fit that flat line the best you can, and that will be the mu. And divide that by the normal force. Oh, you don't have to pan around.
Oh, all right.
Was I out of the frame?
Yeah.
Just tell me to get back in the frame. Say, Mr. Manish, you're out of the frame. How much room do I have? Okay. That's fine if you want to pan. If it makes your job, if it makes you feel, useful.
All right.
I'm sorry, did that come off like an insult? It wasn't intended to be. All right. Okay, so is that pretty clear? Okay, so let's do a sample problem. Let's see. Let's talk about this example right here. Let's say this is a 10 kilogram mass, and the static coefficient of friction is 0.4. So mu sub s equals 0.4. There's no units in that, by the way. There's no units in that coefficient of friction. It's just unitless. So question, how would I set this problem up to find out how hard do I have to pull to break this box free? And you might even be able to do it in your head. How hard do you have to pull that to break it loose?
40, yeah.
40 newtons, yeah. That was pretty easy.
Wait, is that 0.4 or 4?
0.4. Yeah, because what you would do is do the sum of the forces. Let's look at the sum of the forces in the y first. In the y. Is it accelerating in the y? No. Okay, what force is pointing up? The normal force? What force is pointing down? Gravity, so mg equals 0. So then the force, the normal force equals mg. What's the forces in the y? Is it accelerating in the y? No, not at the point it just breaks free. It's not accelerating. So 0 in the x. Sum up over all forces in the x. Okay. What force is in the positive direction? Force of tension. What force is in the negative direction? Force of friction. Well, we've got some real simple system of equations here. We don't know the force of friction yet, but we know the normal force. And we know that the force of friction just equals mu sub s times the normal force. So then we could substitute this into this bad boy right here. So then we have And we can substitute this bad boy into this guy right here. So we have force of friction equals mu sub s times mg. That's, again, I'm substituting this equation into here, just to go slower, in case you guys feel like I'm going too fast. So somebody said I go fast. All right, so this guy I could be substituted in here, and that gives me the force of tension. Then I'm done. So the force of tension just equals mu sub s times mg. The mass is 10. The gravity, you can round up to 10. That's 100 times 0.4. That's approximately 40 newtons. That's pretty easy, huh? Okay. Yeah, some of you are like, I could just look at that and figure it out. Okay, I want to do one more example, then I'm done. Since I talked about it, okay, here's my example. What is the mu sub s of two surfaces that are in contact? I won't write that part. When, I guess that's just a regular sentence. When a block breaks free on an incline. An incline is just a slope, like a ramp. Incline that is tilted to 30 degrees. Okay? Can we find that? There's enough information there to find that? What am I missing?
Wait, this is all for static friction.
Static friction, yeah. That's where the... What am I missing?
Mass is force.
Actually going to turn out that I don't need mass, but we'll put it in there anyways. The block has a mass of 10 kilograms. Put your pencil down when you're done writing that, and I'll erase it because I need the room.
The block has?
Huh?
Has?
Huh?
The block has.
Huh?
Why is there two S's?
I don't know. Because I can't spell. ¿Ya? ¿Está bueno? Alright. Míralo. Okay, so I'm going to define my coordinate system like this. Well, now let's tilt it. I want to tilt my coordinate system. This is the first time you guys see me tilt the coordinate system. Positive is going to be that direction. That's 30 degrees. That's positive, that's positive. And you guys will see why I tilted my coordinate system. Doesn't matter. Is it static? Yes, then the sum of the x is going to equal 0. All right. First of all, let me draw the picture bigger here. You're going to see why I chose to I might need to erase that. I'm going to need more room for my equations. All right, so let's do the free body diagram. Force of gravity, mg. What other forces are acting on it? Normal force. That's always perpendicular to the contact of the two objects. So force normal is right here. What force is keeping it from slipping?
Friction.
Yep.
Static.
Force of friction. And it is static because it's not sliding. Is there any more forces acting on that? Nope. Okay, so and the X is what we're looking at first. This is the X already. This is the X right here. We have a negative force of friction. Do we have any positive forces in there? We have a projection. What do we have a projection of? This is a vector. What's it projecting on? Can it project on X? By project, I mean it has components in X. It does. How would I solve for that? Well, you got to be careful with this one. What's the what do they call it? Complementary angle, or the other? The what?
Supplementary.
Supplement. Yeah. Where is the supplementary angle on this guy? What I do is when I have a drawing like this, I treat this kind of like a plumb bob. Do you guys know what a plumb bob is?
Yeah.
It's a mast that hangs on the end of a string. Because the gravity vector is always pointing toward the center of the Earth. So if I lower this, what's going to happen? What's going to happen to it? It's going to,
Lower.
yeah, it's going to, well, the angle between here and here, is it going to increase or decrease? Increase, so it's not the supplementary angle, it's the complementary angle, right? So you can just choose a different function, like instead of using sine, you'd use cosine, right? For the when you're switching from the complementary to the supplementary, you can just switch signs. You can go from a cosine to a sine. Well, let's keep it the same. You just pick which angle on this thing is going to be supplementary. Let's call this alpha, beta, and this one is just a right angle triangle. That's not going to change. But which one's the supplementary, the alpha or the beta? The beta. Yes. Because as this goes down, beta is also going to be decreasing. Does everybody see that? It's kind of key. So would that be sine or cosine? Would it be the sine of beta to find the projection on X? Or the sine of, or the cosine? It's the sine. So it's mg, because that's the magnitude of that vector, times the cosine of 30 degrees. And what's the cosine of 30 degrees?
Square root of 3.
Yep. Square root of 3 over 2. Good job. All right. So that's that, right? And I'm not going to worry about making this a vector because I'm already kind of in it. They're isolated in their own direction. Now, what's pointing in the what component is pointing in purely in the X direction?
Negative friction.
Yeah, negative friction. Okay. Is there anything else in the X? No, we're done. All right. So catch this on YouTube. You can go to, you guys know how to get to the videos? Go to Haiku, click on lecture videos. And I'm not posting them anymore. I just have at the top a link to a playlist on YouTube. Because it's kind of redundant. I was adding to a playlist and then put them on Haiku. Why not just, you guys have the playlist? All right, so some of the forces and the Y. Oh, the new odds that are not threes to finish up the chapter are what you guys are going to do. So there's like the rest of it, we're finishing up the problems in the chapter.
Are you gonna that on next or?
Probably, but just in case. Because I'm leaving today. I'm leaving early.
There, when you go.
Yeah.
37 to 57 odd. $37 to 57 odd. That's just 10 problems. Okay. Let me finish this one up. If I can get your attention back up here. All right, so some of the forces. What forces do we have on the Y?
The Y. Gravity.
What's the positive one?
Normal force.
What's the negative one?
Gravity.
Gravity, it's projection in Y, right? Since Y is over here,
So
it's if this is, you could bring this, you see this line over here, you could bring this over here, you can move that over here. So what trig function is that? That's the opposite, right? That would be the adjacent for beta.
Tangent, opposite.
Be cosine. It's the adjacent side. Adjacent. So what's 30 degrees of sine? Wait, did I screw up?
Cosine, right? Adjacent and then it's cosine.
That was opposite. We screwed up here, didn't we?
Yes, it's cosine.
I said it was close
you put
enough.
cosine up there.
And then you said it's like, we used sine for the first.
We screwed up.
Yeah, you switched it around.
That should be 1/2, right?
You asked for-
Yeah, because it's a sine. It's the sine. The opposite angle is the x component, right?
Again, opposite.
So we should have used the sine. The sine of 30 degrees
Is 1/2.
is 1/2. So we made a mistake.
I think so.
So forget you, Sebastian. You're wrong. I was wrong. They'll try to prove me right when I'm wrong. All right. So, okay. So then this guy is going to be cosine.
Cosine.
There we go. Is there anything else in the y?
No.
No, there is not. Okay, so we have the force of friction equals mu sub s, which we don't know, right? We don't know the force of friction. This is a question mark. We don't know this guy. But we know that force is normal force. We don't know this either, right? We don't know it. But we're okay though. Why are we okay? Even though I don't know 3 things, what do I have? 3 equations. Yeah?
Yeah.
Okay. Okay, so what can we start doing to eliminate this? Again, we want to find mu sub s is what we're trying to find. So why don't we just plug this into here? Yeah?
Yeah.
So sub it in. Mu sub s, that force is normal force. Okay? Now we don't have F sub n, so what do we do?
With the normal force, the positive root 3 over 2 and g, if you added both sides, then n
Yeah, if yes. So then you could just replace that. You could sub that into F sub n. So boom. So now do you guys see why it doesn't depend on mass?
Yeah.
Because it's homogeneous. I can divide by m and it doesn't matter.
Could you also divide by that?
Well, we can simplify it too, right? We can divide it by gravity. It doesn't depend on gravity. You're right. It doesn't depend on gravity. And that's surprising, isn't it? So,
Could you multiply by 2 as well?
Yes, we can. We can get rid of 2. So now we have 1 minus mu sub s root 3 equals 0. That wasn't too bad, was it? So then mu sub s equals 1 over the root of 3. And can someone calculate that in their handy dandy budget? Point 5 what?
577.
0.57, that's some sticky stuff right there. That's like rubber. So that does pretty good.
Pow.
I'm done. I didn't run out of time. 26 minutes.